Here, welcome back to my YouTube channel. In this video, we will be discussing on VectorStore. And when we look on our data injection pipeline, we have discussed about document loaders, in which we discussed about loading different documents, and we discussed about document splitters, different mechanism for splitting a document, and we discussed about different embedding models. We discussed about OpenAI embedding models, Hugging Face embedding models, and Ollama embedding models. Now the last part of this pipeline is the storing this embedded document. So once the embedding is created, we have to store it somewhere, right? Then only we will able to use it for our project or our other retrieval pipelines. Okay. And in this video, we will be discussing on vector stores, and the basic requirement that we are expecting, you have to be aware of all above three pipelines like loading data, splitting data, embedding data. Okay, so we will not be repeating those processes again and again in each video because that will take too much of time. So vector store, as we mentioned, it will help us to store the document in a vector format, and it will help us to retrieve the document by using some kind of a similarity score or maybe dot product, etc. So there are a lot of vector stores are available like Chroma, Fias, In-Memory, and Elastics. There's a lot of vector stores are available. So we will be covering like couple of vector stores in this series. You guys can definitely go and check the LangChain tutorial for more vector stores. But advantage is they are implementing the common interface, so that if you know one vector store, like you may be able to relate it with the all other rest of the vector stores because their implementation is almost same. Fine. So we'll see how can we implement a vector store, and we can see that how can we do a similarity search with respect to vector store. For that, I have created a notebook, and here we can see I created a 4 documents: document 1, document 2, document 3, and document 4. And vector store is actually required a embedding also. So here we will be using OpenAI embedding. We will be using Ollama embedding. Okay. So this is also we have discussed, and Ollama, what I have done, I have created a Llama 3.2 1 billion parameter, and which is its name is like this: Ollama run Llama 3.2 colon 1 billion parameter to download the model. So I have already downloaded that. And what I will do, I will use the Ollama embedding. For that, we can use LangChain Ollama dot embedding. I can import Ollama embedding, and here we can have a Ollama model. I can specify Ollama model, and the model name is Llama 3.2 1 billion parameter. Okay. As I mentioned, there are different kinds of vector stores are available, but we will be in this video we will be using the in-memory vector store. So I can import the in-memory vector store, and what I can do, I can create a vector store with Ollama. Okay, so here I can specify in-memory vector store, and you have to pass a embedding here. So we already have the Ollama embedding model. We are good to create this. So basic creation part is done. Okay, now here we have a 4 document. Okay, so I want to add these 4 document to our vector store. So let me create it. I will show you 2 different method. Okay, so for that, what I will do, main doc. I am creating a main doc series. Here I will be selecting only the first 2 document. Okay, this is only for the demonstration. We can give all 4 things. Then I am creating a subdoc. Here we can give document 3 and document 4. Okay, let me run all cells again. We are good now. Now we can start. There is a add document method. This will help us to add this document to the vector store. So first I will add our first 2 document. So main doc. Here I am not passing any IDs here. So we'll see how this works. Okay, so this is successfully inserted and we got two IDs. So these are the unique ID with respect to these two documents. Okay, so since we didn't provide any IDs externally, the vector store will automatically create ID for us. In the second example, I can show you and document. I can pass the document as a subdoc. I can pass, and here I can pass IDs. So we can give that it will be a doc1, and maybe I can say it is doc3, and I can pass doc4. We'll see. See, in this case we are getting two IDs that is passed externally. Okay, so in these two ways we can do that. If we are aware of IDs, or if we have a pattern to create IDs, we can pass the IDs externally. Otherwise, the LangChain will handle it internally. Okay. So we have done with the insertion part. Now we can see how can we actually retrieve the document. Okay, and for that what we will do, let me define a query. And here I am just passing a keyword called second. Okay, because if you look on our document, here we can see first test, second test, and we will able to see the weather, and I had a chocolate. So I'm going to take the second, this keyword only, and we'll see the retrieval process. For that, what we can do, I can have a VectorStore Ollama, and here we can have similarity search. Just pass this query. So internally what will happen is this will be converted to vector and we'll do a similarity search. So will be by default it will be doing a question similarity search. Okay, so based on that they have returned a page content first, and it is returning first, second, and it is returning something like this, right? Okay, so we don't know what is the score and how this is calculated, but we'll explain it in detail. Okay, so actually this should be coming first, right? So let me run it again. Okay, so sometimes like something is happening in between. So here when we run the second time, we can see that this comes first, like first, second, and first test, and we can see that the rest of things are coming here. Let me run it again, everything. Okay, then it is first, second, so it is changing sometimes, right? Okay, and quality of this embedding model is also impact. Okay, so if we have using the higher quality or higher llama, then that will give us a more accurate result. We'll see that. Okay, in this this is what we are getting, and what we can check, what is the score for this document. Okay, so there is another method, similarity search with score. Then execute this. So we'll able to see the different score. The first one, the first second will got the 70%, and this one got the 50%, and the third one got 30%, and the fourth one got the 20%, 22%. Okay, and another option with respect to Ollama is like I can say that similarity search with score, and I can say that you just need to return only the 2. By default it is returning 4. If you can check on this, k integer is equal to 4, because by default it is returning 4. I don't need to return the 4. I just need, okay, please out of shape. I don't need like a 4, but here we are getting an error. We can check that. I can say k is equal to 2. Okay, maybe because we are using the similarity. Okay, we are using the by vector. Okay, instead of that, let's use the similarity. See, we are only getting the 2 values from that. So in this way we will able to control that. Okay, if we have a more document and if we need more context, we will able to give k is equal to 10, and if we need less context, we can make k is equal to 2. But ensure that, so whenever we set the context, we have to ensure the model, the LLM model that we are going to use in the RAG should be matched with the context length of our LLM model. Otherwise it will throw an error. Anyway, for now we don't need to think about that, just concentrate on here. So we will have a similarity search with respect to k is equal to, it will return 2. Okay, and we'll see how can we implement the same with what we call the OpenAI model. Okay, and one more thing that we can see, instead of query 1, just I'm passing another keyword, that is weather. Okay, so if you pass weather, so it is showing that first second is okay. Let me maybe run all again. We'll see it will make any difference now. So if you are passing weather, it is actually returning the first second page content as a first document, and actually we expected this weather should be coming first, right? But it is coming last. Maybe because it has a long context, its size is, the page content length is big compared with these two. That's why it may be giving high priority to these documents. So this can be fixed with a different methods that we can discuss in our coming videos. And another way that I need to show how this behavior or this thing will work, the OpenAI models, OpenAI embeddings, because OpenAI embeddings are the one of the best embedding models. We'll see if you use OpenAI embedding, this will make any change. Okay, for that what we can do, we can use the LangChain OpenAI. Here I can import OpenAI embeddings. Okay, I can check OpenAI model and create OpenAI embedding. I'm using the default settings and I have my OpenAI key in the environment file. Okay, now the next is, we already have a, let me have a vector OpenAI. Okay, I can create a in-memory VectorStore. Here we will be using the OpenAI model. OpenAI model. Now we can pass vector.openai.add document. I can pass documents. I can pass a document 1, I can pass document 2, and I can pass document 3, and I can pass document 4. I'm not passing any IDs externally. So let me execute this. Let me run this. Okay, so this is done. Now we can try to query that. If OpenAI dot search similarity search, I can pass query is equal to query. We'll see the result. Okay, so if you look on this result, we can see that the weather is coming first, and we'll see its accuracy also. Similarity search with score. Okay, so if you look on that OpenAI embedding model, it says that the weather is coming first and it has got 83% accuracy, and the first test is got the 78, and the first second is got the 77, and the last one got the 74 score, similarity score. Okay, so based on this we will able to get the correct document when we use the OpenAI embedding model. So what I am trying to say is that the based on our use case, we have to select the best embedding models. Okay, and so this is a typical example. So we see that okay, when we use the OpenAI embedding models, we got the high accuracy, but when we use the Llama 1 billion parameter, we got the less accuracy compared to the OpenAI model. But I'm not saying that Llama 3.2 is the bad one, but because we use the what we call a 1 billion parameter, right? So just try it with the different 3 billion or 70 billion parameter. This may give us more accurate result. Okay, now we can discuss one more thing in this video. We can discuss how can we delete a document from the vector store. So deleting is very simple. So I'm going to delete from the Ollama vector store. Here I can pass IDs can be passed. I'm going to pass a ID as a doc3. This is the one document that we have done. So let me delete, successfully deleted. Okay, so this is also very simple. Okay, so that is all about in this video. So what we have discussed, we discussed about the in-memory vector store, and we tried to compare it with the Ollama embedding and OpenAI embedding, how the results are different, and we discussed about adding the document, deleting the document, and finding with the similarity search. Okay, so in our coming videos we can discuss about couple more vector stores like Fias or ChromaDB we can discuss, and we will see more functions also. So thank you very much for watching my video. Please do like and subscribe. Have a nice day. Bye bye.